Hello everyone, welcome to my YouTube channel. I want to solve this nice exponential question. This question is also a math Olympiad question. Now I want to solve for P where the values of P, if substituted into the left hand side, I must get 1. Now you need to go back to your indices. We all know that any value to power of 0 gives 1. So I've established a fact that the power must be 0. The power must be 0. Now, if the power is 0 and the denominator also must be 1, because I can have 1 to the power of any number. I've established two facts. This, if the power is 0, the second fact, the denominator is 1. So, those are the two things I will use first. And the last one, minus 1 to the power of n. And in this situation, n should be equal to 2k, where n is equal to even numbers, where n is even. In this situation, n must be even. Very, very important, you know that. So I have to make use of these three facts to get the values of p. Let me take it one by one. The first one, like I said, I think that's the easiest one, 1 to the power of 0. So which means the numerator, the power, which is this, must be equal to 0. Let me do that first. I have p squared minus 5p plus 6 equals 0. So if I get the values of p, when I substitute into this, I must get 1. Because if power 0, it is definitely 1. Anything to the power of 0, 1. So this gives, in factorizing this, p minus 3 and p minus 2 equals 0. P is equal to 3 and p equal to. So I have two values of p that can make the power to be 0. So that is already established. So I've gotten p equal 2, p equal 3. So let me look at the denominators, the base, another fact which I said I can have 1 to the power of n irrespective of any value of n. So far the base is 1. So let me pick the base, p squared minus 7p plus 11 equal 1. So in doing this, I have p squared minus 7p plus 11 minus 1 equals 0. P squared minus 7p plus 10 equals 0. Now with this, I have p minus 5, p minus 2 equals 0. P is equal to 5 or 2. P is equal to 5 or 2. Don't forget, I've already gotten p to be 2 before. So in order to add to the answers I've gotten, p can also be 5. I've gotten three values of p that can satisfy the exponential equation. The last part of my explanation of the earlier statement or the earlier fact stated, I said I can also have minus 1 to the power of n, where n must be even. N must. Now, in order to get this, I need to bring out the base, which is p squared minus 7p plus 11, equated to minus 1. The base must be negative. It's a must, it is negative 1. So if it is negative 1, what are values of p that give us even power? That's the next step. Values of p that will give us even power. So let's get the values of p here first and confirm if we are getting even power or not. P squared minus 7p plus 12 equals 0. This is p minus 4 and p minus 3 equals 0. Good. So I have two values of p, which are p is equal to 4 or 3. Now I've already gotten 3 before, and don't forget, this brings me back to this. Like I said, n will be even when this is negative 1. N can also be 0 even if it is negative 1. Yes, n can be 0. So Let me substitute these two values back into the base. I'll put them into the base, into the power rather, and see if the one that will give us even and the one that will not give us even. So I'll put p equal 4 in p squared minus 5p plus 6. So 16 minus 20 plus 6. 4 squared is 16 minus 20 plus 6. This gives 2. So this is even, which implies that minus 1 to the power of 2, this is 1, which implies that p equal 4 is one of the solutions, one of the values of p that satisfy this. Now let me check the last value, which is p equal 3. I'll put p equal 3 into this, minus 5p plus 6. So 3 squared, which is 9. 9 minus 15 plus 6. This is 0. Yeah, n can be 0. If n is 0, I got p to be 3, which is already established before now. Therefore, I have 3 values that satisfy this equation, 4 values rather, that satisfy this equation, 4 values of p. P can be 2, p can be 3, 4, and 5. Thank you for watching, and don't forget to subscribe to my channel. Bye.